And now it is our favorite segment, plotting. And this will be not tough at all because I know you guys have been plotting for a very long time. So if there is a card which is standing still, what should be its x by t plot? Standing still in one dimension. Now we are talking about 1D plots. So standing still in x dimension at some position, suppose x naught. This is the origin. This is the positive x-axis. Always define the axis first. That's the rule. Okay. And this distance is x naught. Okay. So if it is standing still there, what should be the xt plot?
Line parallel to t
Line parallel to t
passes through x equals to x naught.
Yes. So that is your xt plot. The very basic things all of you already know. This is the plot. What about vt plot?
Sir,
Inclined straight line.
Like this.
no, sir, it will be the
No,
x,
sir, it
axis itself, the t axis itself,
T,
because it will be zero, velocity will be zero, always zero.
Coincidence to t.
Yes. It is coincidence on this t axis, right? Because velocity is anyways always zero. This is velocity, this is time, this is acceleration, this is time. Okay, what about acceleration?
Again, coincidence to t.
Again, coincidencing here. Great. So these are the plots you are easily able to make, right? Move on to next plot. If this guy, instead of standing still, it is moving with constant velocity, that is v. Constant velocity is there right now. Okay. So after time t equal to 1 second, it is here. After next 1 second, it is here. After next 1 second, it is here. So it travels this much distance per second. So it is traveling at constant velocity. This is what we mean by constant velocity. Traveling constant amount in constant time without changing its direction. Without changing its direction. So it is not changing its direction here. Yes. So what should be the plot?
So what is
of
its
xt?
position at t equals to 0?
T equal to 0, its position is suppose x naught.
Okay. So
This is the origin. This is positive x-axis. And thank you for asking this question. Yes.
it will be a straight line passing from passing from x equals to x like x naught, like t comma x naught, and the slope will be v. The velocity will be the slope.
Yes. So it is some kind of this line x naught. It will not go in the negative direction. You know this, right? Because time is never negative. It should start from this point to upward. So this is a wrong part. Should not draw it. But this is the plot. This is x versus t curve. Okay. Yes. What about VT curve? I want answers from everybody now. Some of you are not speaking. So what about Mithal? What about VT curve?
So it will be a line parallel to T and passing
passing through
some value V.
V naught. Yes. Whatever the value of velocity that is, V naught. Yes. And what about AT plot, Akshaya?
Sir, it's a curve that it's like a parabolic.
Do you think this guy has any acceleration? It is traveling with constant velocity.
No, sir, it will be 0.
Yes. So what should be the plot?
Origin. Sorry, in
Origin?
x-axis.
On x-axis, right? So this should be the plot, right? On the x-axis, because it is not having any acceleration. Okay. Now let's talk about the more general case where this guy is moving but with a constant acceleration. So in 1 second it has traveled this much distance, in another second it has traveled this much distance, in the next second it has traveled this much distance. It is moving and covering different distances for the same interval of time. That means it is accelerating, and the acceleration is constant. That's what we assume here. Okay, acceleration is constant. Then what should be the plots? Yes, I want answers from okay, Ayushi.
Sir, for xt, it will be from
Okay,
Sir,
let's the better thing is to start from at instead of xt
okay,
and go on the
sir.
other direction.
Okay, then plot is parallel to uh, T, sorry, A naught.
Parallel to a naught.
No, sir, at parallel to T.
Okay, at the value some a naught,
At the,
right?
yes, sir.
Okay, yes, this one. Now, since acceleration is constant, velocity is changing.
Yes. Then it is inclined straight line.
Inclined straight line starting from
V naught.
some v naught. Yes, whatever the
Some V naught.
velocity was there initially at time t equal to t naught, it starts from here. Okay, so this is a straight line. Why is it a straight line? Because this is a constant acceleration. So dv by dt equal to constant, and if dv by dt is constant, then v is of course some constant times t, and this is y equal to mx kind of equation. Okay. Yes. So now the third one. What about x? You know the equations for constant acceleration, equation of motion that relates x with t wonderfully. It is x equal to x naught plus v naught t plus half at squared. So what should be here, Yoshi?
Sir, a parabolic curve pointing upwards if the acceleration is positive. Like if it's accelerating motion, then starting from x
Starting
naught.
from x naught, concavity upwards, right?
Yes,
Yes,
concavity.
sir.
Concavity is upwards. Parabolic curve with concavity being upward. Why is it parabolic? Because it is c plus bx plus ax square.
AX square.
Okay.
Okay.
Yes, so it is that kind of a curve. That's why it has to be a parabolic curve. It is a parabolic curve. If acceleration is negative, it should be concave downwards. Okay. Yes. This is what happens. Great. So in negative, we are assuming it is positive acceleration. That's why all three are the plots. If we assume negative acceleration, then the velocity should decline from v naught continuously, and this should be concave downwards. Okay. Yes. So this is the last segment of today's class, which is what does it mean for these three plots. Okay. What is the slope of the tangent for this plot? Slope of the tangent is given by dx by dt. You guys know this. Slope of the tangent of xt curve is given by dx by dt. Slope of the tangent of vt curve is given by dv by dt. Slope of the tangent of at curve is given by dA by dt. Okay, what is it? What does it give you? Slope of the tangent. You see,
Velocity.
which kind of velocity?
Instantaneous velocity.
Instantaneous velocity.
Yes, instantaneous velocity. What does this give you?
Instantaneous
Acceleration.
Instantaneous acceleration. Okay, what does this give you?
jerk.
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 Okay. So this gives you jerk. Now area under the curve. What is the area under the curve if you have yx? What is the area under the curve? It is y dx. So
is
here
there,
it is x dt. Yes.
so is there something like average jerk?
Average
Jerk.
jerk or
Yes.
instantaneous jerk. Okay. I don't know about that right now, but this gives you a jerk. It has to be instantaneous jerk because it is a very small time interval. So it has to be instantaneous jerk in a very small span of time. How does this acceleration change? So it has to be instantaneous. Okay, but I don't know if there is something called average jerk or not. So
Yes.
maybe I have to figure it out. Okay. Yes. So
Sir,
this is x
mathematically
dt.
we can have those type of quantities, but assuming it physically, I am not having any examples for that. But mathematically we can have average jerk and
Mathematically we can have, yes, but physically that's what I want to figure out. Yes. Yes. So what about integration x dt? Does it carry any physical meaning whatsoever? So this is the area under the curve if it is y-axis. So this average jerk, we'll talk about it. But
No, sir.
if yes,
Sir, I don't know. Like I don't know the any physical quantity representing
okay.
this thing.
So there is no such physical quantity right now, which tells you this, which gives you this. Okay, integration x dt. So there is none. But what about this integration v dt? If you look this equation closely, then this is equal to v, and you take v that side, take integration both sides. What does it give you?
So displacement.
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 Displacement. Sorry. Yes.
So area under the curve is displacement. Yes. What about integration ADT?
Velocity.
Which kind of velocity?
Means, sir, like didn't get you.
Instantaneous.
Is it instantaneous or average?
Average. That will be average. If
Average,
we are
average.
integrating over the whole like curve, then
Yes. We'll be talking about a big graph. If it is AT graph, we'll be talking about a large interval of time, and then we'll be talking about area under the curve. So it has to be average velocity. Okay.